Hey everybody, welcome back to Web Components in Space, episode 4. So, like I said, we're going to be building a music application today. When I say building, though, we're not going to be doing all this stuff from scratch. I have it built, and I'll show you some key integration points for some of the technologies and tools we're going to use along the way. And I want to start with Web MIDI. Now, Web MIDI, MIDI is the musical instrument digital interface. So I happen to have a Korg X3 keyboard. I want to say it's 20 years old, but it's the same MIDI it's always been. It still interfaces with my computer. This is a standard that's been around since '83, I think. So long-time standard, works well. It's been in Chrome for quite a while. Unfortunately, no other browsers support it that aren't Chromium-based anyway. And also, unfortunately, I couldn't find a lot of good examples online of it in use. And partially it's because you have to have a nice little musical instrument that supports MIDI, like I have right here. So I found a kind of a cool demo. So it's very simple, but it's called Get Your Notes On. So you can see right here, you're shown a musical staff, and you're supposed to press the right note for this, right? So this is an F sharp, so I'm gonna hit an F sharp on my keyboard here. And it says I am correct. It also told me the velocity, so let's try that again. So this is a C. So it told me my velocity was 86. Let's try to hit it a lot harder. Let's go for, this is an A. So 92 versus about 60. So yeah, I'm on a good path. I'm answering the quiz correctly. Let's just try to, nope, it didn't like that so much. So yeah, it's kind of a nice little quiz game, kind of in the spirit of the app we're building. Play the right notes for the right situation. So the next thing I want to show, it's very cool. Honestly, when I was putting this feature in, I was just putting it in because it was cool, but it's actually pretty useful. So this feature is pitch detection with the web audio API. So there's no web API, there's no browser API for this. You're just using the web audio API and analyzing the fast Fourier transform, or the FFT, of the audio signal that's coming in and trying to gather what frequency you're singing, how many hertz is that, or what note you're singing. I gotta admit, I don't know how to do this at all. I could probably spend months and learn it myself, but this person, Alex Ellis, put out a great blog post in March of this year with a great sample that, honestly, I just kind of ripped off and copied into my code and then kind of refactored as my application was built. So here's what he has: detecting pitch with the web audio API and autocorrelation. And so we can try it out right here on his blog post, and I'm gonna round to the nearest note. Let's try starting, and you can see as I'm talking, it's trying to pick up what note I'm speaking. And that doesn't really work that well if I'm just speaking, but if I sing a constant tone, let's try this. There, I sung a pretty good F there. So let's try going up and down. So I was a little sharp. I really didn't hit the notes I wanted to hit, but you can see that it worked pretty well when I fed it a constant tone, and you can look at this visualization right here, drawn on the canvas. It's all pretty cool. So I had to pull this into my application because, you know, it's when you're playing keyboard, I wanted to judge what you're playing and make sure you're hitting the right notes. But you can also do that when you're singing as well. So I thought this was a great feature to add. But you know, Alex gives a great explanation, even draws some diagrams for you if you want to get to the nitty-gritty of how this works. So it's all good stuff. But the source, like I said, source is right here, and I pulled this in. And it's not very long, honestly. Look at this. Most of this is draw note, draw frequency, all stuff just drawn to the canvas. So the actual mathy goodness is all down here for trying to find what note you're singing. Now, the last audio goodie I want to explore was Tone.js. Tone.js has been around, I want to say years. I used to use it back in the 2010s to try out different audio things. Basically, it's an audio synthesizer. So why do I need a synthesizer? Well, let's take a look at this app we're building today. So I called it B Sharp, and basically you play some notes on your keyboard, and it judges how correct you are for the chord you're trying to play. So what if you don't have a keyboard? Well, we can use this virtual keyboard right here. With Tone.js, we can make a little noise here. And so this works with the application. So if I want to start my quiz, it's asking me to play an F7 in the root position. If I don't have a hardware device that supports Web MIDI, I can just do it here. So F, A, C, and then I think E is the 7th. No, D sharp is the 7th. Also, here's another reason I'm using Tone.js, metronome. So we have a metronome built in this application, so we can start that metronome. Kind of ticks down with a timer so you can time your music. Let's make this go really super fast, 160. Yeah, so there we go. Honestly though, I'm barely scratching the surface of what Tone.js does. Let's take a look at some of these demos here. Oh, here's a good one, Face the Music. So this one is pretty wacky. It's hard to use, but at the same time, I gotta appreciate what they're trying to do here. So let's play it. Basically, I am going to attempt to play music with my face. You can imagine this goes all sorts of badly. Well, let's just try it out. So you can kind of see these visuals take off when I move different parts of my face, especially opening my mouth and opening my eyes. So it gets those pieces to light up, and I got to imagine this is using probably the TensorFlow Face API. It's kind of a throwback to our last episode where it's pose tracking. This is cool. So, as I said before, these audio toys, these goodies that we're exploring today, they're really fun to play with, but I don't think they're applicable to web components. And the reason is, if you don't see them on your screen, I don't think they belong in your DOM. I don't think they belong as a tag. So when we're working with audio, I think it's fine just leaving it as JavaScript. We don't need a tag for this stuff if we don't see it. So where does this leave us with web components? Well, here's the thing. Lit 2, new in Lit 2 are reactive controllers. Now, reactive controllers, Lit 2's been out for a while, so if you have not used reactive controllers, I think you're in for a treat. It's kind of changing some of the patterns I've long had when building components because it's such a nice way to work. So what are reactive controllers? Let's turn over to the Lit documentation and take a look. So it's a new concept for code reuse and composition. It hooks into the component's reactive update cycle, and I'll stop reading verbatim right now. I'm going to jump to the example that I really like, which is all the way at the bottom. So here is the example for the mouse move controller. So as we look at this example, you can see as I move my mouse, the X position and the Y position, the coordinates are getting updated in real time here. And if you look at the sample component here, it doesn't look as complicated as what we would need to do to actually make this happen. It's rendering the mouse.position.x and the mouse position.y. Where does this come from? It comes from a reactive controller here. Mouse equals new mouse controller, and we pass in this as the component. So let's imagine what we'd have to do if we wanted all that functionality here in this very component. So we'd have to add a mouse move listener, and then from the event that comes back, we'd have to grab the client X and the client Y, and then we'd have to request update because we want our template here, our lit template, to update with the coordinates, the X and Y position. So that's honestly all that code would kind of make this little component here twice as big. So we can kind of shove all that logic off to the side with a reactive controller. So let's look at the instantiation here. We're saying mouse equals new mouse controller, and then this is our component here. So we're passing this, or our host, into the reactive controller. So when we look at the reactive controller here, the mouse controller, You can see the constructor. This is where we're passing in our host, our component. We're saving our reference, and then we are adding the reactive controller to our host. Now, when our host is connected, we add our mouse move handler. We add our event listener. And when our host is disconnected, we can remove that. So this is where we're grabbing the client X and the client Y from our event, and we're updating our property and then saying request update on our host. And again, the host is the component that we instantiated this with. It's our my element component here in the example. So this is kind of this seems very organized to me and very kind of elegant. It puts all this boilerplate code for whatever we want to deal with. These properties, they aren't reactive by nature. A mouse listener, these coordinates, they aren't reactive by nature. We can't declare them as reactive properties in lit. And there's a whole bunch of other things we couldn't do that with because they're just not our properties. We can't declare them in lit as such. So what can we do? Well, look at this. We can add a reactive controller and push all that logic off to the side so we can deal with these reactive properties like lit intended very easily. I don't know if you're as much of a lit nerd as I am, but these reactive controllers are kind of changing the way I want to solve my problems. So it's almost as fun as working with web MIDI, pitch detection, Tone.js. Not quite, but it's almost as fun. Anyway, that's about all we want to explore, except for one last major thing, and that is CSS or style for web components. So I think if you're watching this, you probably know how to style a web application with CSS, but you know, especially with the Shadow DOM, there's some nuances to working with web components. There's some ups, there's some downs, and I'm excited for our next guest to explore that with her. Her name is Cassandra Roberts, and she's writing a brand new book on CSS in web components. It's going to be out soon. So I won't be exploring CSS right now because I want to jump into our conversation with her. So stay with me. We're going to be chatting with Cassandra Roberts up next.